Merci Valérie. Bon après-midi. Thank you so much. I am very honored and pleased to be here today with you on behalf of Foratom, which is the trade organization of nuclear energy in Europe. And you immediately notice that this is the diversity of Europe. This morning we had a panel with the US representatives, and I would not say they were always speaking for a single voice, but of course, it's basic in Europe. When you address nuclear and not just nuclear, it's a diverse situation. So I'm really happy to do this, and I'm very proud of the composition of the panel we have this afternoon. Many friends, by the way, many stakeholders, or do I dare to say shareholders of Foratom. Mats has been my president for 2 years, so I have to take this into account. What I would like to do in this afternoon, so we have decided to spend just a few minutes for each of them illustrating their national situation and their national problems, if any. And then we would really like to dedicate as much time as possible to the discussion with you. So we will have plenty of time for you raising questions, hopefully getting some answers and contradicting the panel this morning. Let me just make a few introductory points. When it comes to the European view on nuclear, we should always recall that Europe is ranking #1 in commercial nuclear worldwide. We are operating 132 reactors in Europe, which is about 30% of the European electricity for more than 40 years without any accident and any contamination in commercial reactor operated in Europe. So I think we have to be proud of this. We have high-ranking utilities everywhere in Europe, and industry, the vendors, the equipment providers, etc., are very efficient and, again, ranking #1 worldwide in all the fuel cycle activities. So I think we have to be proud of this, and I'm very happy to repeat it. But so that's why it's legitimate to have an EU-wide view on these nuclear activities, and hopefully we have something to learn from each other, and that's precisely the goal of this afternoon session, learning from each other and sharing this experience with you all. Now, if there is an EU rank or a European #1 in nuclear, again, it's diverse, and especially for our US friends today, you know, there is not such a thing as Europe, no such a thing as an EU-wide licensing process. There is no such a thing as an EU-wide safety authority. We do have a treaty which was designed 60 years from now called Euratom, which was organizing some cooperation in nuclear activities, but we are not that far to have a harmonized system with a single safety authority, a single regulator. We do have cooperation between the regulators, as you just noticed from the previous expose, but we still have some progress to do. Now, in 2011, you know, there was an accident in Japan, and it's really important noticing that the European industry, the European regulators, the European policy makers, they decided to immediately draw the lessons from this accident, and collectively we did a safety reassessment of all the 132 reactors in Europe, and the conclusions of this very long effort, and by the way, 500 man-year dedicated to this effort, was positive. The reactors in Europe were considered as safe, but there were some ways to improve them from the point of view of safety, and that is precisely what we expect from our speakers today to tell us how they did this in the last years. So I really think that it's important to have this look together. Again, as it was already quoted this morning, it's just common practice in industry to think at long-term operation. We do this in other industrial sectors than nuclear energy, so it's just a way to materialize the continuous improvement that every one of us is used to. So that's exactly what we would like to address. We do know that at the end of the day, there is a balance to strike between the safety requirements, and again, we do hope to learn something from each individual member state's experience. On the one side, the safety requirements, and of course, on the other side, the economics of this, and depending of each individual country, the balance may be a bit different. So I suggest that without further ado, we spend now a few minutes listening to all of them, and we do expect from them to speak 5, 6, 7 minutes, I mean not half an hour. So allow me to be very strict on this. Please use 5, 6, 7 minutes, but not more. We expect from you that you illustrate your national situation. We do have 6 very high-level representatives of the European utilities and companies, so I'm really excited to, not to chair, but to moderate this discussion. And again, without further ado, I would like to start with my left-hand colleague, Jean Van Vief from Electrabel. To avoid any misqualification, I have asked each of them to tell us exactly what is their position in their company. Jean, you are the first one.
Thank you, Jean-Paul. I'm very glad to be here today. I don't know whether we are coming on Belgium. So I am in charge of nuclear assets and projects at Electrabel. It means the nuclear support, fuel and core liabilities, but mostly major projects that we had to run, like long-term operation, the stress test, quite recently also the issue with the reactor pressure vessel of Doel 3 and Tihange 2, and also one side of end of life is also decommissioning. As you will see, some plants will very soon enter a post-operation phase and decommissioning. So in Belgium, we have 2 sites with 7 nuclear power plants, all of them pressurized water reactor of the Westinghouse technology, supplied, entry-plus supplied by Westinghouse of Areva. And as such, Belgium has decided in the 70s to transpose all the American rules, regulations, standards, and not to set up their own ones. So we are using and applying US regulation, but the principle of periodic safety review has been foreseen from the start, and there we are in the European and IAEA process. And we do, of course, in the meantime, follow WENRA regulation. Concerning the operating license, in Belgium, initially the license was unlimited in time, coupled to pressurized water, put to periodic safety review. But political situation was quite complicated in 93. In 99, we had a government with Greens on board, and as a result, Belgium voted a phase-out law in 2003. Could say that the vote at the parliament was quite reluctant, but it was an agreement. And this law foresees 40 years of commercial operation, but there was a clause of force majeure in case of risk of security of supply where the government was allowed to take decisions. This was a situation, those having the periodic safety review process and a lot of improvement in the plants. In 2009, we were approaching the 40 years for 3 first units, because you see on the slide, Doel 1 and 2 and Tihange 1 were commissioned in 75. This was the first wave of power plants, while the 4 other units were commissioned between 82 and 85. I must say that, so we were approaching in 2009, we were approaching 40 years. I must say that between the 2 waves of plants, there is a big difference in design. The last 4 units integrated a lot more of internal and external events in their design, like commercial size, airplane crash, gas explosion, and so on, that made that the reference design for these plants was higher. And in the frame of periodic safety review of the first 3 units, we already, after 10 years, implemented a lot of design improvement. Before even WENRA said something about that, we were already implementing changes that were trying to bring the oldest units closer to the design of the last 4 ones. Now, concerning regulation on long-term operation, in 2009, there was a memorandum of understanding signed between GDF Suez and Belgian government for a longer operation of the Tihange 1 and Doel 1 2 by 10 years, combined with a sharing mechanism of the profit between, between the utility and the community. This was not translated into the law, except that the profit was, of course, shared, and we got a nuclear tax of 250 million euro per year that was brought to 550 million euro a year now, which is about 12 euro per megawatt hour. That has to be paid every year. In 2013, last year, the phase-out law was slightly modified. The phase-out is maintained to 40 years, but Tihange 1 has been extended with 10 years. So Tihange 1 will be able to operate 50 years, as you can see on the slide, LTO. So Tihange 1, starting in 2015, will be extended by 10 years. All the other plants should stop either in 2015 for Doel 1, 2, and Tihange 1. The Doel 1 is in its last cycle now, will be shut down on 15th of February next year. And there is no force majeure clause anymore. So the law says, and if the law doesn't change, all these plants will have to close in the last one in 2025. I should say, the energy policy foresees to compensate that with energy savings, renewables, and the only idea of the minister is now to subsidize potentially the construction of gas-fired plants, while all utilities are closing all gas-fired plants as being uneconomic. So you see the nightmare in which we are living today in energy concern. But this will have to be, we have to live with that for a few years before we will see that it will be impossible. On the regulator side, the regulator published their requirements for LTO, which is quite in line with WENRA. It means we have, in the frame of the fourth periodic safety review, addressed 3 domains: preconditions for LTO, showing that we are ready to run the plant more than 40 years, in organization, management, and so on. Management of all aging issues, and particularly for time-limited equipment and for qualified equipment. And finally, there is a request of making an upgrade, safety assessment and upgrade to come in line with the WENRA philosophy of being as close as achievable to most modern standards. So we have decided to perform LTO. The file for Tihange 1 and Doel 1, 2 was introduced in 2012 and accepted in 2011, excuse me, and accepted in 2012, 3 days before the decision of the government to stop Doel 1 and Doel 2. So we are now implementing the long-term operation program for Tihange 1, which is a quite heavy program, 600 million euro in total, studies, aging, replacement, and modernization. It includes a new emergency building, it includes a new full-scope simulator, it includes a lot of replacement of INC and electrical equipment, and replacement on the balance of plant. This is a big program, and the law has been voted last year, and the agreement with the state was signed last week. So we know exactly now the conditions at which EDF and Electrabel, the owners of the plant, will be sure to finance the modernization. This agreement foresees also a mechanism of sharing the profit between the owners and the state in case the market price will go quite above the minimum price that is fixed in the law. For the industry, and for my company in particular, LTO should be only decided on the basis of safety and, of course, economicity. It's a cost-effective way of producing electricity, and by the way, today nuclear plants are the only one producing profitably. So closing the only profitable plants in a country seems to be a quite silly option. It's also a way to control CO2 emissions. So, as I said, the plants are very modern. As you can see on the slide, we have replaced the steam generators on all the units. We have operated 5 of them with 8 to 10%. We have made a lot of modernization on aging issues, on design issues in the frame of the periodic safety review and after the stress test, while there is a minimum investment because they were already quite modern. The last 4 units, as I said, to give you an example, like some Swiss plant and German plants, have an emergency, additional and different emergency systems in a bunker protected against airplane crash that can automatically shut down the plant for any external event. And they are totally different, have a remote and have another, for instance, not ultimate extinct than the normal one. So we think these are modern. They could be extended their life, or they could go for operation for a very long time with minimum investment. So, but today the law says no. These 4 units, 5 units that will be in operation have to close between 2022 and 2025 and supply today 50% of the electricity in Belgium. So the reason why the group recently put to zero the value of all these thermal assets, but said it will not do it for the nuclear because we are convinced they will be prolonged. So policy is today, keep the LTO option anytime, and we will stay modernizing these plants to the last day of their operation, regardless of a positive decision of the government today.
Merci beaucoup, Jean. C'était vraiment ce qu'on attendait. Thank you so much. Yes, you can. So you did notice that it was not just about economics and safety, but also a bit about politics. And I guess it would probably not be the only one when we will address some specific political issues. Now, moving from Belgium to the Netherlands is we are very used to, so we are close to each other. So I'm really pleased to give you the floor at Louter from EPZ in the Netherlands.
Thank you very much, Jean-Paul. My name is Ad Louter. I'm CEO of EPZ, who owns and operates the only one nuclear power plant in the Netherlands. Our location is in the southwestern part of the Netherlands, so we're pretty close to Rotterdam, but also pretty close to Antwerp, to Doel. It's only 60 kilometers away. We're located at the River Schelde, so we use the same cooling water, more or less. Our plant was established in 1973, so last year we celebrated 40 years anniversary. And actually just a couple of weeks ago we received the irrevocable LTO permit after a decision by the High Court of State in the Netherlands. I think that was a very important decision, obviously, for us, but one of the and obviously the opponents were the NGOs, usual suspects, I would say, but they called for an additional environmental impact analysis, and that was, I think, an important, very important subject in this case, that the court has ruled that there was no need for an additional EIA since we just continue our operation. We don't intend to do anything different than yesterday. Now, going back to history, we have a German design plant, Siemens KWU, so from, I would say, one of the first ones from the convoy principle, and I think we're pretty proud that it is proven to be a very robust design, so it's still in a very good condition, particularly the pressure vessel, but also we still have our initial steam generators, and there's no need to replace them, and that's obviously, from an economic point of view, very important. One thing to add on the LTO process, I think the mechanism are more or less along the same lines as Jean already mentioned, and also this morning by Mr. Alexander Biskov from IAEA. He perfectly mentioned all the way we have been. Particularly also 1 or 2 months ago, we concluded the Salto mission, the third mission, 2009, 2012, 2014, to get a good impression whether we are ready for another 20 years. So now we have a permit. It is limited. It was unlimited in time. Now it is limited, and we can continue operation till the end of 2032. Now, one of the specifics of the Netherlands, and again, it's political, is that we had some, I would say, dynamic times somewhere between 94 and 2006, because then our horizon changed from 40 years back to 30 years and then up to 60 years in just a couple of years. And it starts in 94 after our second periodic safety review, when we planned quite huge investment in modernization, same as Jean mentioned, bunkered systems, 5 diesel, emergency diesel generators, a number of deep well, so additional makeup and decay removal, ultimate heat sinks. That's all what we did. And this investment, well, I would say largely exceeded the initial investment of the plant back in 73. So it was a huge investment. And only a couple of years later, the Parliament decided that we should close in 2003. And then the plant itself and the Labour Council, they started a court case against the Dutch government, and they won. So the plant could not be closed. And then, obviously, our government had something to solve, which happened in 2006. And then there was a covenant between the government and EPZ and its shareholders, and it allowed the plant to continue operation for 20 more years. And there were a few conditions. One was that it should remain very safe. Actually, it should remain in the top quartile of safest plants, nuclear plants in Europe, in United States and Canada. And this benchmark should be done every 5 years. So the first result of this independent international committee was published last year, September, and it said, indeed, we are well within this top quartile group. So that was, again, good news. And the other thing is we do not have a nuclear tax. Happily, we do not have a nuclear tax. It was not invented in the Netherlands, but we have a condition that we should invest 250 million euro in renewable energy, CO2 reducing energy, so to stimulate the transition from fossil to renewable. And that's the other condition which we are continuing to fulfill. So basically, I would say that's the story of the Netherlands. Thank you.
That was it taken. Thank you so much. Again, I think about beyond safety and economics, obviously we were back to politics, even if the countries were different. Again, that demonstrates that there could be an issue with the decision makers. So you demonstrated as well that without slides you can be convincing as well, so thank you so much. Now I'm moving back to the north of Europe, Mats. So I'm really delighted to open the floor to Mats Ladderborn, representing Vattenfall in Sweden. As I told you, he was my president for 2 years, so I would say it's increasing my pleasure to give you the floor, Mats.
Hello. It's on. Thank you. Mats Ladderborn. I'm responsible for nuclear development in Vattenfall. And I tried to present the Swedish case. And, well, to start a little bit, do you have the, yes? Thank you. Yeah. Well, also start some country outlook, perhaps. And here you see a slide over the 10 reactors that are in operation in Sweden. And those reactors stands roughly for 40% of the electricity production in Sweden. And the rest comes more or less from hydro. And yes, you could see we're from the west coast, Ringhals, and they went into operation, yes, between 75 and 82 years. And then we have Barsebäck that has been closing down for political reason in 99 and 2005. I come back to why and the reason behind it. And then you have Oskarshamn on the east coast, 3 BWR reactors, and they went into operations from 72 to 85 as well. And last but not least, we have Forsmark with 3 BWR reactors, and they went into operation between, well, 80 and 85 as well. And looking from the political perspective, we have a deregulated market in Sweden since 1995. So this price is set on the market, and the spot price is rather low today. Going back a little bit about the history in Sweden, there was a referendum in 1980 after the 3 Mile Island saying that we should close down all the reactors in Sweden, but do it gently, and they should be out of operation by 2010, the latest date. But there was a negotiation between the government and the industry, and it was a decision to close down Barsebäck, and then the government opened up for long-term operation in Sweden. But they were clearly saying that we should fulfill modern requirements if we should operate a longer time. So they clearly said to the regulator, put forward new regulation, and if the industry want to continue operation, they should fulfill modern requirements. Well, what's happened more recently is actually 2011, there was a law changed in Sweden that make it possible to build new nuclear in Sweden, or replacement bill we call it. You have to close down one reactor and then you could erect another one. So actually we have started that work from a positive side. Well, leaving the politics and the country outlook, going to the safety authority, what they have done, and as I mentioned, they put forward new requirements 2004 or 5, something like that. And the requirements are the same as we heard here before. It's more or less up to modern standard. You should be able to, well, have your plants operating as generation 3 or 3+ in some cases. And there was a negotiation between each plant and the regulator putting forward a transition plan. And we had to show whatever modernization we should, well, carry out in able to reach those standards. Of course, you cannot do everything, but we have done a lot. And then I would say, yes. So now it's actually, the licenses are eternal, and it's a 10-year periodic safety review in Sweden as well. And of course, it's been judged by the government, not the government, the regulator. Then, of course, after Fukushima, we will have a new regulation in place. So 2015, it will be updated even with some tougher requirements, I would say. So what have we from the industry done? Yeah, you could see the lifetime on the last column, between 50 and 60 years. You could roughly say the plants that went into operation on the 70s, they are planned to operate for 50 years. And the plant went into operation 1980s, they are planned to run for 60 years. But this is, of course, a matter of discussion with the regulators during the 10-year periodic safety review discussion. Also mentioned that it was allowed in Sweden to have power upgrades, and you could see that there has been not only a lot of refurbishment from long-term operating perspective, we have also done rather heavy power upgrades in Sweden. The red one are not really in place, but you can see between a couple of percent up to 30% is actually with power upgrades. So this is, of course, done in the parallel with the modernization from a long-term operating perspective. And I could just mention some project that has been very, very tough. The Ringhals Unit 2 has a 10-year project of changing INC equipment with a total brand new digital control room. And of course, the planning was perhaps for 4 or 5 years, but it was double that time. It took 10 years. And I would also say that there's been rather heavy outages. So on this slide, you could see that the period in middle here, there's been very heavy modernization period. We have a reactor standing still for more than 1 year for outages. So, of course, I would say this period has been very, very heavy, and we're not through it. It comes with another period now with the, perhaps the Fukushima event taking care of that problem. But you can see here the production of the nuclear in Sweden, and hopefully it will be a stable production going forward, and then we have to see what we could do in the future. That was the Swedish case.
Thank you very much, Mats. We did not just move north to Sweden, but you were explicitly referring to what somebody this morning called the bridge between LTO and new build, and I'm thankful to you for this because this illustrates the further step. Now, I invite you to participate in an exciting experience crossing the channel. We stay in Europe, but as you know, it's always an experience to move to the UK, so I'm delighted to give the floor to Mark Hartley on behalf of EDF Energy. So it's a French name, but it's a British company.
Thank you very much. Good afternoon. It's a pleasure to be able to be here and speak to you this afternoon. So I'm Mark Hartley. I'm Engineering Director for EDF Energy Generation. And I'll briefly cover the current status of civil nuclear in the UK, the UK context, and then move on to really how we approach plant life extension to try and give you a bit of a view for that. Just push the button. So the current position for nuclear has developed since commercial nuclear generation began in the UK in 1956, peaking in 1997 with around a quarter of the UK supplies coming from 16 nuclear stations. Since then, 7 stations have entered decommissioning, leaving just 9 still generating. EDF Energy's nuclear fleet comprises 8 stations in the UK, with the remaining Magnox station owned by the UK government and expected to cease operating later this year. There are 7 AGRs, these are advanced gas-cooled reactors, which were commissioned between 1976 and 1988, and they are unique designs. And there is 1 PWR, which was commissioned in 1995, which is a 4-loop Westinghouse design. 6 of the AGRs were built in principle as sister station pairs, and they are far from identical. So long-term operation of such a unique and diversely designed fleet presents a significant technical challenge. Ongoing investment has allowed us to extend operation of several of our existing plants following thorough safety reviews. The next station being considered for further life extension is Dungeness B. In our group results announced in February, it was announced that EDF Energy expects to be able to extend the life of Dungeness B by 10 years to 2028, with a decision expected later this year. Based on the expected life extensions, all 7 of our AGR stations will be operating in 2023, when the new nuclear power station at Hinkley Point C is due to be commissioned, if a final investment decision is taken later in the year. So moving on to the UK environment. We now have a great deal of support for nuclear in the UK. And last year we saw all major political parties agree that there's a place for nuclear power. Support from the public remains strong, with polling consistently showing a majority of people in support of the use of civil nuclear power. Of course, the incident in 2011 at Fukushima raised legitimate questions about the risk and safety. In the UK, there was a measured and rational response from industry, from the public, and from the government. Openness and transparency are important ambitions for us at EDF Energy. To help promote a dialogue with the public, we've been reopening visitor centres across the country, and each of our power stations now has one. So this long journey to deliver openness, always with a backdrop of strong independent regulation, has led to the UK environment today, where the public see strong government policy, a strong independent regulator, and a strong operator. Proactive discussions are held so the operator presents a well-considered, confident view in line with government policy that meets the required safety standards so it can be supported by the regulator. The UK has also committed to some very challenging emission reduction targets. The new nuclear, therefore, has been recognised as an essential part of the mix. In 2010, the British government gave the go-ahead for up to 8 new nuclear power plants. And EDF Energy has plans to start the next wave of new nuclear build in the UK, starting with 2 EPR reactors at Hinkley Point C in Somerset. However, in the meantime, existing nuclear stations will play a key role in achieving the UK decarbonisation targets. So the case for long-term operation can really be broken into three questions. Can we do it? Should we do it? And will we be allowed to? So can we do it? Whether we can extend operation of the AGRs or not is limited by the two key non-replaceable components, which comes down to the graphite core and the boilers or steam generators. The key to predicting lifetime is modelling and validation through plant inspections. The key to actual lifetime is real plant condition as measured through inspection. In assuming that the non-replaceable graphite and boiler systems will determine lifetime, we have thereby also assumed that all other aspects of the nuclear business are successfully managed to enable these new lifetime planning dates to be achieved. Therefore, the next stage of our journey is underway to align all aspects of our business, internally and externally, to these new dates. So technically, we can. Should we? The question of should we do it is really centred around economics, given the need for energy, and assuming we must always demonstrate that we are at the absolute highest standard of safety. There are, of course, two main factors: the investment needed to secure long-term operation and the wholesale price of power. A lot of effort's gone into establishing the investment needed to deliver long-term operation and applying strong controls to be sure we deliver what we're committed to. While the price of power is outside of our control, so we've taken a view in the business case as to how this will factor in. The existing nuclear fleet provides the most affordable, large-scale, low-carbon source of electricity in the UK. So long-term operation of our nuclear power stations makes absolute sense in terms of filling a short-term energy need while the country continues towards aggressive decarbonisation targets. Finally, will we be allowed to? Here I return to sort of where I started, which is that public trust is absolutely key. In addition to that, we've seen reform in the UK's electricity market, creating the right investment framework for all forms of low-carbon energy, including existing nuclear and new nuclear build. So the government policy is framed. Lastly, providing we demonstrate that the plant meets the required safety standards both now and for a planned period of future operator, then the regulator will be supportive. Thank you very much.
Thank you very much, Mark, for this highlights of the UK specificities. Now, you probably know that Switzerland is not an EU member state, but we are used to include you with us, Philippe, and I'm happy to see you with us today. We will now learn about the Swiss specificities, because I think there are some as well. So please, you have the floor.
Thank you, Sean. Thank you, Jean-Paul. It's a real honor to be here today. So my name is Philipp Hanke. I'm the managing director of Swiss Nuclear. And Swiss Nuclear is a platform where the different owner of the Swiss nuclear power plants can actually coordinate their interests. And we do this on the whole field, from very political to very technical questions. So we are an organization a little bit similar than the Nuclear Energy Institute in the US, just much, much smaller. Starting a little bit with electricity policy in Switzerland, we have 8 million people and we consume 60 terawatt hours of electricity a year, 60% of which is actually produced by hydropower, which is roughly half dams, as you see on the pictures, but on the other end also running river plants. The remaining 40% are produced by nuclear, which means that actually the full production of the Swiss electricity is CO2 free today and since very long past. At the time of early 2011, Switzerland actually had 11 license application planning to build 3 new nuclear power plants to eventually replace part of the existing fleet. But then after the Fukushima accident, the Swiss government took very fast decisions because we were half a year before elections, so that was long enough for the politicians to take action, but short enough to be afraid of the election. So already in May of 2011, the Swiss government announced that there will be no new licenses or no licenses for new nuclear power plants in Switzerland of today's technology, whatever today's technology means. So they decided to give no new licenses so that the pending applications will not be granted. But at the same time, they also announced that there will be no change to the licensee scheme of the existing reactors. And what that is, I will explain a little bit later. The plant you see on this slide is Betznau with the units 1 and 2, and up to my best knowledge, Betznau actually is today the oldest commercially operating nuclear power plant in the world, because it started operation in September of 1969 with Unit 1 and is now into 45 years of operation. It's a PWR unit from Westinghouse. Then we have 3 more sites in Switzerland. One is the Gösgen site with a Siemens KWU 1000 megawatt plant, then which started operation in 79. Then we have Leibstadt with a GE BWR6 Mark III from 84, and the Mühleberg plant, which is actually the smallest plant in Switzerland, with 370 megawatts, which is an older GE BWR4 Mark I containment, which is in some way similar to the Fukushima 1 unit, just that it is much differently backfitted, and it was implemented in the beginning in 1972. Now, about the licensing situation in Switzerland, the Swiss law only knows an unlimited license, so all these 4 sites or 5 units have actually unlimited licenses. So they can be operated as long as they are safe, and the goal is not to operate the license expires. The goal is that you operate as long as you're safe and economical. To balance a bit this unlimited license, the Swiss law also knows very strong backfitting rules, and these are basically made up of 4 items. One of it is that you have to implement the learnings from operation experience from your own plant, but also from all the plants globally, and adapt to the safety levels necessary from international experience. Then the second and the most prominent one is that the Swiss law says that you actually have to implement the state-of-the-art in backfitting technology. So you cannot implement the state-of-the-art in safety, because some of the things cannot be backfitted, but all, let's say, safety features that improve the safety of your plant and can be backfitted, we actually have to backfit. So we are basically in a continuous state of backfitting, and you can call it also long-term operation, because from the very first day we don't see an end to the license. So we can and want to invest in the plant to have, for the foreseeable future, the opportunity to produce electricity. Then the third rule, that is, besides the mandatory backfittings you have to do additional backfits as far as they reasonably reduce the hazard to the public, or as much as they reasonably increase the safety of the plant. So even if it's not necessary, if it's not a standard, if you can significantly improve the safety of the people, you have to do it. And then as a fourth measure, we also have the periodic safety reviews, where every 10 years we actually make the analysis of all these things we actually need to implement, if they were successful, and what we know to do for the future. So we know the periodic safety review, but we basically work continuously on safety, as I'm sure many of you do. What I can also say maybe about this slide, you see that all the 4 sites are on the German-speaking part of Switzerland. Some of them are actually even very close to the German border, which then also gave the German media a very big impact during the discussion after Fukushima. So we share the same language, and we sometimes also share the same TV channel. Coming to a concrete example, what it means to do continuously backfitting, what you see here again is the Betznau plant, which started operation in '69. And the owner of the plant, Axpo, actually invested over the history of the plant around 1.6 billion Swiss francs into the plant, which is 3-fold actually what it originally cost. So then backfitting the safety investments into the plant are a factor of 3 of the originally purchasing price, which also makes it clear this is not the same plant anymore that was originally purchased. And it may be the oldest plant in the world. It's certainly one of the safer plants in the world, and it actually had very good results performing on the European stress tests, which actually shows that age is important, but age alone is not a factor about safety. It's actually what you do with the plant. And even now, and that was decided before Fukushima, they decided in 2009 a further investment program of another 700 million to make sure that this is the oldest plant in the world for quite a foreseeable time frame. When you want to go to the menu or wish list of the things which were backfitted there, it's nearly everything you ever heard of. We have digital INC, we have full scope simulators. We installed this specially bunkered emergency system, so we have airplane crash proof, earthquake proof, diesel generators, shutdown panels, and whatever you need we have in a special bunker. We also have filter containment venting, hydrogen recombiners. So whatever you can backfit, we have to backfit, and we did. And this is actually true for all of the Swiss plants. This is just one example. All of them are in a very good condition. Despite of that, actually, one of the plants, which is the Mühleberg plant, which is the smallest one in Switzerland, decided in autumn of last year that they will actually shut down the plant in the end of 2019. And the decision is an economical one. They just decided by today's electricity market and the backfitting they would foresee for the next 10 years. They decided for them the operation of this small plant is not economical, and so they will shut it down at the end of 2019. Thank you very much.
Thank you very much, Philippe, and specifically illustrating the continuous improvement process that you did undergo in Switzerland. Now, last but not least, I'm happy to switch to the Czech Republic, which is a nuclear country for many years and with a strong utility and a strong industrial basis. So we are delighted to learn from your own experience in the Czech Republic. Tell us about the Czech Republic.
Thank you very much. First of all, it's a great pleasure for me to be here because our company has cooperation agreement with EDF, and we have great long-term cooperation with our French colleagues. My position in our company is Technical Support Section Director, responsible for long-term operation program and engine management programs. Here is a short overview of our utility. We operate, Czech utility operates nuclear, coal, wind and gas power plants, not only in Czech Republic, but in Bulgaria, Poland and Romania too. We have 2 power plants under construction, one gas and one fossil power plant. With this gas power plant is connected not very happy story because it should be put into operation this year, but because of low electricity prices, we are thinking about conservation. And similar story is connected with our public tender for 2 nuclear units in Temelín site because it seems that because of low electricity prices this project isn't profitable. There are big discussions about these projects. Here you can see location of our power plants. Our coal power plants are located in north of Bohemia, around coal mines. We have several hydropower plants around Vltava river and two nuclear power plants south of Bohemia. Both of our nuclear power plants are Russian design VVR. From long-term operation is more interesting Dukovany site because the first unit at Dukovany was put into operation in 1985, and as compared with Western design, our Russian types reactors have design lifetime only 30 years. It means that we are going to ask for a long-term operation permission for Dukovany next year. Our legal framework is very similar to other European countries. We can't talk about license renewal because we have permanent license, time unlimited license, but we have to ask every 10 years for operation permission, which is based on periodic safety review, based on actualization of final safety analysis report, and based on other requirements coming from our regulatory body. Operation permission for long-term operation, there are some additional Czech regulatory body requirements which are based on IAA SALTO recommendations. This unlimited license looks like advantage, but in fact we have to ask every 10 years for long-term operation. It means that for 6 years we have to ask 3 times for long-term operation permission. Our long-term operation program consists of 5 parts. I think that most important part is technical economic study, which aim was to evaluate technical feasibility and economical profitability of long-term operation project. And as I've mentioned, low electricity prices, it seems to me that now the long-term operation project, Dukovany long-term operation project, is maybe only profitable project of our company, because all 3 scenarios, plus 10, plus 20, and plus 30 years, has really strongly positive NPV. This picture looks quite difficult, but I would like to show only the full scope of our long-term operation project, which is based on IAA SALTO guides. And it is very important to mention that long-term operation program is not only evident preconditions as periodic safety review and design basis and configuration management programs and so on, but very important parts of long-term operation projects is, for example, human factor, knowledge management, know-how transfer, because aging is connected not only with equipment but with staff too. And for example, for average age at Dukovany site is nearly 50 years. Here is an example of corrective actions or modifications, replacements, and exchanges for scenario plus 10 years. it is more than 200 actions, and you can see three numbers. They are capital costs of 3 long-term operation scenarios. The plus 10 years scenario is relatively cheap because Russian design is quite robust, and operation plus 10 years doesn't need any important replacements. And on the other hand, scenarios plus 20 and plus 30 years are very similar because all important replacements must be done after plus 10 years scenario. Very important for us is international verification because the very important requirement coming from our regulatory body is to prepare our long-term operation project in accordance with best international practice and international requirements and recommendations. Very important for us was IAA Salto peer review mission in 2008, and now this year we are preparing for full scope IAA Salto mission in Dukovany. Here is only summary, everything was said. Our technical economic study demonstrates technical feasibility and economic profitability of long-term operation up to minimum 60 years. Our safety part of our long-term operation program complies with IAA Salto recommendations, and maybe important remark, Temelín is only 10 years in operation, but we started preparation of long-term operation for Temelín too. Thank you very much for your attention.
Well, there we are. This closes the panelist presentations. I told you that you could expect the European diversity. I think this was a very fair illustration of the European diversity, not just the individuals, but the technologies they are using. But I would like also to underline some similarities, and in particular the definitive commitment by everybody to operate the nuclear reactors as safe as possible, but also as long as possible. Now, we have, I would say, about 40-45 minutes, and the floor is yours, because now I would like to suggest that you take advantage of the high-quality executives you have here around the table to answer your questions. So please feel free to raise your hand so that we can identify you. Please tell us whether you would address the panel or some individual in the panel. And then, who's going to start? Yes, over there.
Jean-Pierre Lovis, Sven, Rhône 1, Loire. Monsieur Jean Van Vif, Belgique. In English, excuse me.
If you don't mind, yes. I think he would understand French, but...
yes. So we heard 1 or 2 years ago some problems about vessels, cracks in the steel. What's exactly the position about that now?
Jean.
Yes, as you probably know, we had to instruct the case, and it lasted to May last year. And in May, we received the authorization to restart the 2 units, and they have restarted effectively in June 2013, which associated to this restart an action plan to be completed before the next outage. Next outage is in May and June, so we are pursuing this program, mostly 2 actions of importance: the qualification, formal qualification of the inspection technique, and characterization of material, including characterizing material properties after irradiation. So this is specific. Of course, this will be an issue for long-term operation, you understand, but at least the plants have been authorized to restart after very intense review and are running very well.
Thank you. And McClellan over there.
Yes, hello. Yes, I'm still Anne McLaughlin.
It's good to know.
Yeah. My question goes to Mats Latterborn. You told us that a couple of the reactors, the older ones in Sweden, are planned for operation for roughly 50 years, and the others for roughly 60 years. Had you not had the luxury of having a law that allows you to replace the capacity on the same site, do you think that the decision would have been different? In other words, would the operators want to try to squeeze a few more years out of the older plants too?
That's a good question. But I think so here, it's not coupled, so I would say each plant look at its own business case. So I would say the answer is no from a former perspective, but on the other hand, I cannot say from a perspective of more feelings. Of course, if you know you could replace the reactor, there could be some influence in that direction, of course. But more or less, each plant has its own business case.
Thank you, Matt. Yes, over there in the middle.
Claude Fabre from retired from EDF. I have a question because I am very surprised by the cost which has been quoted by all the people here for extension of life operation. I heard, I not mistake, that in Holland it was about 200 million of dollars, and in Switzerland it was about 2.3 billion of Swiss francs, which mean about 1.5 billion of euro. So there is a difference about a factor 5 between Holland and Switzerland. So I am very surprised because all the plants are at about the same level, at the same age, and the difference of improving could be the same.
So, Ant or Philip, are you ready to comment on this? Ant?
Yeah, well, actually, I didn't mention a number. And it's not the number you mentioned, for sure. It's a bit more. I would say it's about 600 million euro for 20 more years. And that comes very close to what Jean van Vive mentioned. And I always have a difficulty in conversion to Swiss francs. They go up and down. But I think I'm also in the same ballpark as the Swiss. And actually, the report that was mentioned this morning, the OECD report about the economics of LTO, gives very good indications there.
Yes, I say also that Tihange 1 is about 600 million, but you know that if you replace an equipment, after you will not have to do it after 10 years. So if you do an investment to extend the life beyond 40, it's probably good for going to 60, but we are only authorized for 10 years, some more years. We probably think that going to 60 years instead of 40 or 50 will not be very different. In fact, is a need to make design improvement, which is very important, and also once the equipment has slightly reached its end of life, and it is the case especially in Tihange for equipment, we have no formal qualification today. In fact, they were designed in the 70s, they have no formal qualification, and the regulator says that if we want to go beyond 40 years, we have to replace them with formally and fully qualified equipment, electrical and INC, according to the recent standards. So there was a kind of authorization to run 40 years with not formally qualified equipment, but for going beyond, we need to have qualified equipment, and so we have to replace.
Thank you, Jean-Philippe. Are you ready or available or willing to comment?
Well, I guess on my slide you saw pretty clearly that the investment of what you quoted, the 2.7 billion Swiss francs, was over the full 40 to 50 years of the power plant. So it's not just to go from 40 to 60 or to go from 40 to 50. It was the whole investment over the lifetime of the plant so far, within view that it still has an unlimited license and that you would like to have as much safety margin as you can for unforeseeable events in the future, so that you don't need immediately to backfit or to shut down because of new things you learn. So I would just say this plant is in an extremely good condition because we really put a lot of money in it. But you also have to see where it started in '69, so things which we built into the plants that started operation in '79 or '84, like the specially bunkered diesel generator and shutdown panels and all these other things, they had to be backfitted, and that were quite expensive backfits in the '80s and '90s.
Thank you. Danesh and then Mats.
I would like only to say that this, according to my opinion, this overall number very strongly depends on methodology and timing. Because, for example, back to my numbers for number 4 plus 10, or relatively cheap scenario plus 10 years, it is important to say that we've done a lot of important replacements, for example, INC replacement many years before starting of long-term operation preparation.
Okay, Mats?
Yeah, just want to add one thing is that, of course, you have the project cost, what it costs to upgrade the plant. But on the other hand, you have, well, a standstill with not any income from the plant. So you must take that into consideration also. So you have to sum up with the project cost and the loss of income from the electricity as well.
Thank you. Who else? Yeah. Yeah, thank you for standing up.
Thank you. I'm Laurent Pontieux from Rolls-Royce, but I'm going to ask a question with my hat of a representative of the French nuclear industry. So my question is about sustainability of the supply chain, and the question is for all panelists. How do you see are the challenges or the strength of the European supply chain to support your plant extension programs?
Thank you. A very short question, but I guess wide answers. Who's ready to start? Danesh.
It is a very, very good question because one of requirements of our regulatory body was to prove or to demonstrate capacity of our supporting organizations and vendors for long-term operation, for the whole period of long-term operation. It means it is one requirement to officially declare or to officially prove and demonstrate capacity of external organizations and vendors.
Who's willing? Just before giving you the floor, keep in mind that one of the added value we are expecting here is to learn about possible shared experience from all the utilities you are representing. So if you have something to say about the potential sharing of experiences, I think it would be worthwhile for everybody.
So again, I think an excellent question and a key challenge for us. The learning point, I think, with where we've gone in the UK has really been that by having the end dates, the business planning dates set down, that allows us to align the whole business behind that. That very much includes the supply chain as well. So we've gone down a route of working hard where we've identified key partners to build long-term relationships, set up agreements that we're starting to put in place against the expected lifetime of those plants.
Thank you, Mark. Mats?
Well, yes, I think it's, of course, you cannot blame the supply chain. I think we as utility has a big responsibility as well. You cannot sell out responsibility. So I think this is a combination that we have to learn from. But I could say, you could see on my slide, the last slide, that we had the availability from the plants. We had a really, really dip under a couple of years. And I would say we had underestimated completely the complexity. And when you do this big modernization, you go really into the design basis of the plant, not the design basis of a system or a part of the plant. You go into the design basis of the whole plant. And this is really what we have underestimated. It takes so long time. So I mentioned one of the projects took more than 100% longer time to carry out. And actually the outage were actually, well, nearly 3 times as long as we have suspected. So this is a common responsibility. We have to understand what we are doing and not only see the upside of the project. To be honest, we have done that too much, see the upside. We could add some features, we could add some value. And okay, some come say there's risk associated with this, but to be honest, we have, I would say, not look at them too deeply. So I think we have a lot of lessons learned, and of course you're welcome to come to us. We have done a lot of mistakes, but I think in the future we will hopefully do it better.
Thank you. That might be the start of wisdom, Mats. Yeah, Jean.
Yes, I have something to mention. I talked about replacement of qualified equipment. It was mostly instruments that are qualified for working in local environment or so on. And there is really an issue of non-standardizing between the countries. In fact, an equipment which is currently qualified to be used in EPR may not be used in Tianjin because the standards for qualification are different. So we have to requalify a lot of equipment. It's very costly. And also suppliers that still know what to do from the past are often very limited. So we are really coming to a situation where for a long time there was very little volume of supply of supply for them, and many suppliers disappeared. Or if they had taken over another one, they maybe have some equipment in their list of references, but they don't know the equipment anymore. So we have next to being able as a utility to come back and to find the original information on equipment that were supplied in the 70s, which is a question of physical configuration. We also have to find suppliers that can supply this equipment as it was in the past. So it's a big issue. And I think part of the issue is on the industry side, part of the issue is also on the regulator side, to be able to standardize the requirements for equipment.
Thank you, Jean. It's obviously something basic because we are now, I was illustrating and underlining diversity, but at some time in the process, there are also some drawbacks from that diversity. So I hope that we can maybe later on share some lessons from this. Yes, Had.
Maybe I can add one more thing. I greatly agree with what Mats Laderborn said about utility responsibility. As we have seen today, and as you mentioned, Jean-Paul, we have a large installed base in Europe, and almost 50% of it is approaching the 40 years age. So there's a huge job to do in terms of LTO. But it's particularly about knowledge with the suppliers, and also about getting it in the slots, in the windows of the outages, that you do not lose too much of electricity. That's a very important point here, I think. And there's one more remark I would like to make, is that there's one big country of Europe not in this panel here, and that's Germany. We have a German design, so we're largely depending also on the knowledge of German designs. So it is a concern now, this German Atomausstieg.
Thank you. Yes, of course, we are aware of this. And by the way, we do not expect the Germans to be very contributive to what Alexander Bischkov was calling the bridge to NPP, to new build. So anyway, they are still present. But is there any lessons, or no, I would say, is there any suggestions or proposal you would do, learning from the others' experience, about what to do on behalf of industry? Because all of you, the 6 of you, plus my organization, we are representing industry. Is there something we should do or propose or recommend to the regulators or to the governments to improve the efficiency of this long-term operation for everybody? No? Not at this stage. I'm back to the floor. over there. Bernard, tu l'as vu? Oui.
Yes, Didier Bautier from Areva. I understand that up to now the long-term operation has been considered by each of you as interesting and profitable for the future compared to other options. But there is the question of the perspective on electricity market now in Europe, with a trend on electricity prices, which perhaps is a risk to consider for the future, for the 20 years coming. So could you comment on this question of the perspective of electricity prices on the market, having in mind that the expansion of renewable energies have a definite impact on the market and should extend in the future, generally speaking, in Europe?
Merci Didier. Did you aim at somebody in particular or the panel?
Everybody is concerned around the table, with perhaps a specific case for the UK, but...
Okay, let's start with the UK, but nobody will escape. Mark.
Yeah, I mean, in the UK, we're in the position with a deregulated market, but the electricity market reform has now really put things in place that shouldn't disadvantage existing nuclear and fits in very well with the overall policy for an energy mix. Clearly, we've seen an approach from the way the government policy has been put down, which encourages renewables, but also provides an incentive in terms of the possibility for new nuclear build. So overall, I think how that's been approached provides a balanced incentive. Clearly, there's still a risk in terms of where overall those prices go to long term, and that's something that you have to factor in terms of any considerations, certainly for plant life extension or long-term operation.
Jean?
Yeah, if I look to the Belgian market, it's very small and quietly interconnected. We see now first is a slight, slow and continuous reduction in consumption. Partly because of a lot of initiative in economy of savings, also because the industry is leaving. This is really a heavy concern. Belgium is a heavily industrialized country with big consumers. Steel makers are almost closed. Metal bought everything and then closed. The chemical industry, very strong in the Antwerp area, is really looking at displacing its production facilities in the US. And so this is accentuated by the fact that renewables, and especially solar, is taking a part on the domestic side with a rush to roof coverage of panels. So I think for the moment, and you have seen the statement of many, the most of CEOs of most utilities, if there's not a reform in Europe on the market, we are going into the wall, definitely. We're closing all our plants, we are cutting value of our plants. The situation is very hard. So long-term vision today is very hard for companies who are struggling to survive. And easily, really struggling to survive. We think there will be a replacement market at a certain moment, and probably the nuclear will have to be replaced because even with the effort on equipping the renewables, we are far, and in Belgium we probably will reach 17 to 20% in 2025 if we succeed to develop renewables. Because in last year, wind onshore is systematically challenged in the court. So it's not a single project, or almost no project are going ahead anymore on onshore market. They are all challenged in court. So I think Euro has to reform its market to make it again working. I think that LTO will be part of the answer, but also the recovery of the market price is the major part of the answer. Otherwise, not a single utility will invest anymore.
Yeah, thank you, John. It's not just about producing electricity as cheap as possible, but also selling that electricity, and I would say as profitably as possible. Who else? Yeah, Philippe.
Well, I can totally agree that the low electricity price in the market is a big problem, and as I said before, one of our plants actually announced to shut down in 2019 because their estimation of the future prices is low enough that they believe their plant is not profitable anymore. But that's by far not the whole picture. The bigger problem is that actually the game has changed, and the business model that were very profitable in the past are not profitable anymore. So besides the fact that the prices are low, how you actually earn your money is not so clear anymore for a utility. And to give one example, let's say for Switzerland, pump storage used to be a reasonably good business, even though investment costs were extremely high for some of the facilities. The spread between low prices you could use to pump up water and then high prices during peak demand you could use to turbine the water, and even though you lost some energy, you basically, on the spread of the two prices, you can make good profit to pay back your capital cost. That's a model which works less and less today. One reason is because the spread became much smaller, which means the peak prices are not as high anymore because solar energy produces during peak price, peak consumption. And so the spread is much smaller, and then we have the other problem that while we use the plants to optimize for economical reasons, or buy low, sell high, as everybody would do, today the plants should be used or maybe regulated to use to stabilize the grid, which not necessarily is exactly the same thing. So if you're regulated to use the plant actually to compensate for the erratic production of some of the renewable energies, you are not able to use it in the most economical way. And then on the other hand, you have many, many small producers with wind turbines or with solar roofs who come into the market and don't see the price because they have a fixed feed-in tariff into some of the country and will feed in electricity at a time you don't need it. And the grid operator or other utilities have to compensate for that. And all of that makes it much more difficult for a utility to have a vision actually on how to be profitable in the future. Then you have all the changing regulation in the different countries. You're not really sure what the law is going to be in 5 years because part of the situation today is obviously unsustainable. And in that condition, it's extremely hard to make an investment case for anything. Maybe gas, even solar. You're not even sure if you have a case for solar today, which will be a good case because it's subsidized by the government. You're not sure if the government is going to tax solar in 10 years because they're short on money, and your nicely calculated business case is suddenly no business case anymore because you not only have a fuel tax, and we have a hydro tax, you will eventually have a solar tax to make sure that the government keeps the money it actually needs to feed in for the feed-in tariffs, because printing will not be a solution in the long term.
Thank you, Matt. Do you want to further comment?
Just add one thing, as the same situation goes, of course, for Sweden. We have a business case looking for eventually replacement bill in Sweden, and we should do it, of course, on no subsidy whatsoever, and we have a deregulated market. But I think it's very important for the decision makers to understand that you cannot only look at the production cost for a specific production unit, whatever it is, solar, wind, or whatever. You have to look at the system cost. What is the total cost for the system going forward? And I think we have to look 20, 30 years ahead of time. What kind of system do we want to have? And what are we prepared to pay for that? So shifting from going to look about production costs for a specific unit to look at the system cost, I think that's very important.
Thank you. Who else? Didier, yeah? It's a privilege to get a second chance.
Just to follow my question, I think perhaps in the future, the specific advantages of long-term operation of nuclear power should be better rewarded by the market because of the reliability of the supply, because of the continuous availability of power which is offered by the nuclear power plants. So there is, to be optimistic, I would say, perhaps we could hope that in the future market design, the value of the service provided by the nuclear power plants under operation could be better rewarded in the future. Now, I want to make another remark to be also very positive for the future. I think the case of Besnau plant, which is the oldest and perhaps one of the safest plants in the world, has to be emphasized. Because many people think that the older the plant, the less safe it is. And I think it is very important to have this example of Besnau, among others, to show that it's not the case. Older can be safer.
Thank you. Bertrand, oui?
Merci. Bertrand de l'Épinois, Areva. We heard very impressive examples, as was quoted by Didier for Besnau, of continuous improvement and backfitting of the plants to be top of the class, even with early designs. In those examples, what is the part of the industry initiative and what is the part of the safety authority request in this process and in this continuous improvement and up to that level?
Thank you. Who volunteers? Mats.
I could start. I think it's a very good question, of course, and I think the same goes that we as utilities, we have the responsibility to have the highest safety and have continuous improvements. But of course, sometimes when you put a new regulation in place and you have some really hard pressure, of course, that helps out in a way to do it faster. So I would say in Sweden, we had a continuous operation until the new legislation came in place, and then we had a really rapid modernization phase where we actually forced to implement higher backfitting standards. So I think, of course, it's a mix.
Thank you. Somebody else? Mark?
I think in the UK, one of the things that actually helps in terms of the behaviour, particularly for the operator, really driving forward implementing those standards, is we do have a goal-setting regulatory environment. So that encourages the behaviour of the operator to always be looking ahead and saying, you know, how do I need to improve continuously to maintain those standards? And that behaviour has, you know, come over a long period of years. So I would say in the UK, it's very much driven by the operator as a starting point in terms of what is it that we need to do in order to meet what might be considered relevant good practice, given whatever recent events in the world are. Clearly, the regulator will then take a view on whether they believe that's acceptable or not.
Thank you. Jean?
I think effectively two parties are pushing. I want to remember that on the operator's side, you have of modernization. You have also a lot of action on the operation side, on the way to perform, on the way to operate, and there the cooperation and the action of the peers are very important in improving the way we practice on the day-to-day, on managing the knowledge, on exchanging experience, on maintaining, on operating. And exactly because excellence is of course having a good design, but excellence is also operating the plant very well. It means remember safety is not only made by the design, it is also the operator and all the barriers and the processes you put in place every day to have a strong culture, to have a very responsible and knowledgeable operator. And there are a lot of effort that were made by the operators, and we can certainly see the success of the US industry in achieving high performances and consistently by effectively working hard on the way they practice and they share and they even push to the best practice in operating the plants. Probably that in Europe we were much more pushing and the regulator on the design and the improvement of the design, but don't forget safety is in the hands of the operators and comes from their way to effectively day by day live safety.
Yeah, but thank you therefore, but we are again representative of the industry. Do you consider, thank you for this, would you consider that there is enough room or institution, not necessarily institutions, but places when all the industrial partners together you can share and benefit from the experience of the other ones? Is it, from your point of view, satisfactory? Do we miss some opportunities, or how would you appreciate this? Is there enough room for exchange? Because we are so diversified. Nobody? Are you satisfied with the current way you are working?
Well, in a way, I will answer your question, but I understood the question of Bertrand Lépinois as how could industry facilitate utilities in this LTO process, and my obvious answer would be that I would encourage you to come up with competitive offers and make sure that your execution will be flawless. That would help us best. I think the nuclear industry, and I've worked in aerospace industry and oil and gas industry, is still a bit conservative industry, and where we take nuclear safety as our overriding priority, it does not mean that execution of projects could still be much more efficient.
So, who feels conservative? Matt?
Yeah, surely. I think we could do a lot better, to be honest. We could hear this morning from the United States how important it is with lessons learned and, well, everyday share information. And to be honest, I think we are not up to really that good standard in Europe. We could have a lot more lessons learned from each other. And but I also have to emphasize that we have to need standardized things over the countries, because we have the same suppliers, and I think the safest plants are when you could really share information between them, and then you have to, in a way, have a standardized way to doing things. So I think we could learn a lot, to honest, from the industry.
We started today.
Yeah, well, for one is, if I would buy a French car or a Swedish car, it needs to be approved in one country, and then it fits all European countries, for instance. Such ways of thinking, if we look at Lean and Six Sigma initiatives in automotive, in microelectronics, there are still steps to make in our industry, in this part, without ever compromising nuclear safety.
Do we dare to call for more harmonization from the regulator side of the panel? But it's maybe another question. Who else? Yes? Xavier.
Thank you, Xavier Pouget-Abadi, EDF. I would like to get a reaction from the panel to the WENRA position to consider as a reference for LTO and as a prerequisite for LTO for existing reactors, the safety objective which has been set up for new reactors, and to know what are your considerations in terms of practical consequences, pragmatic implementation. And by the way, in the draft of the Nuclear Safety Directive, this safety objective for new reactor will have to be considered when the directive will be enforced as a reference for existing reactors. So I'd like to get the views of the panel. Thank you.
Thank you, Xavier. Who is ready? Jean?
This was part of the exercise we had to do to introduce a long-term operation file to the regulators. So one of the things they had requested is to make an assessment of where our plant design was positioned in comparison with the requirements for most modern reactors. While the standard was not so clear at this moment, when our reference level were not for new reactors were not finalized yet, but the exercise had to be done, and we had to come with some practical measures. And one tricky question was, of course, about severe accident and core capture. And of course, the answer was, well, to maximize prevention, but also the decision to implement a filtered containment vent with high performance if we went for LTO. It means more on the mitigation side if we cannot avoid the reaction and we cannot catch the core properly. But this is one of an example. But effectively, we had to do quite formal exercise of comparison. And in many cases, we came to the conclusion that backfit that was made in the past has already brought the plants relatively close to the requirements for next generation.
Thank you, Jean. Did some of you share this experience? I mean, the same kind of request from their own from your own regulator? Matt?
Yeah, I can just comment. I think we had more or less the same process. As I mentioned, 2005, there was new regulation coming in. It was more or less, not really as the vendor standard, but more or less that we have to comply and show how we comply with new requirements from the old reactors. And we have the same process right now. The regulator in Sweden will put forward new regulation 2015, and this will be for new reactors, because we have handed in an application in Sweden for new reactors, and the new regulation will be according to, I would say, vendor reference levels, for sure. And this will be added to the old plants as well. This will be the same regulation. And we have asked the regulator, how should we cope with this? And we don't really know yet. But of course, we have to do some analysis and show that this, in a way, pragmatic, we could meet it with some, well, analysis and showing we cannot implement the core catcher, for instance, or other measures, but that we have done enough backfitting to really fulfill the wording of the new standards. So it's a good question, really, and we have to face it, really.
Thank you. Hope this contributes to increasing the confidence of the public. Mark?
If I may, I'll just add one point. For me, this returns to the conversation we were having earlier about reasonable practicability. And I think as long as that is a part of the way the regulation is applied, then it's a reasonable approach, and we can look at it in that way. And I think it's also very important that we have in mind that there are different ways to achieve an equivalent risk reduction or an equivalent standard. So we have to be careful that these things, if they're to be widely applicable, are not too prescriptive. So.
Thank you. Yes, over there, in the middle.
Antoine Jouan, Sven Rhône-Vallée. There is nobody to speak us about what happened in Germany today. Of course, there is a nuclear power plant which are still in operation up to more than 8 years. And what about of them? Have they been improved? Does somebody of the panel answer my question?
So, the question about Germany, of course, I'm not entitled in no way to answer something about Germany, but Mark, Philip, I'm afraid you are the closest one to Germany. Would you volunteer?
And the most exposed.
I don't ask you to tell it in German, but you can tell us about this, if you have any feeling about this.
Well, I'm not sure I can really elaborate on that, but I mean, the German plants before Fukushima were plants in the best conditions in the world, so the safety standard was very high, backfitting rules were very strong, they were under huge scrutiny. And so after the decision to shut down within a period of years, they still have to do some more investments into the plants. They are not totally cut back, but they also have a huge safety margin, as you could see in the stress tests. And I mean, just by looking at their designs, so that I personally see no problem for them to operate for another 8 years, which is nearly true for every plant. I mean, that if you decide to shut it down today, in 4 years or so, nobody should be as close to a safety margin. That 1 or 2 years additionally is very crucial. And with the German plants at that age and in that condition, 8 years should not be a significant number if they are normally maintained, as I'm very sure they are today in Germany. So that time, if they would, you see, it's much more difficult if you announce a shutdown in 25 years, and you have, then is the question, what's your investment plan at the end? But in the time horizon of 5 years to 10 years, the plant should have enough safety margin to operate there.
Yeah, I guess that the goal of the organizer when they decided to dedicate that session to long-term operation, that they did not immediately had in mind to invite the Germans because they were phasing out. We still have, let's say, a few minutes for a last question, if any. Yes? Ah, there are two of them.
Denis Janin, working for Ayant in Germany. So
there we
I might
are.
give a few small comment on that. Although I'm French, I agree with a remark from the Swiss colleague. The German plants are in a quite good condition. Before Fukushima, we had some plan to upgrade the power, in some plants. So linked to that, we had some safety also improvement program. But of course, it's now been cancelled. I can also share that before Fukushima, the topic aging management was of high focus. We were in all those new GENIA and also initiatives in the scopes. Of course, it's now behind us.
Thank you. It was rather a comment and an answer than a question. So thank you very much for your contribution. And then I saw somebody standing up. Yes.
Pascal Guin-Coris, simulation vendor. I have a question about the procurement and tendering process for that kind of project. And to clarify my question, I will try to explain its context. So I assume that those projects are very complicated, very difficult to describe through a specification, and that a vendor that has already an experience will have a tendency to overweigh the risk and then increase its price, while a newcomer will, I would say, underestimate the risk and give a price that will be seen more attractive. So does any one of you intend or has already implemented some innovative process for the tendering of such project?
Well, thank you. Time has come to demonstrate that we are not conservative. Does somebody want to answer? Mats?
I could start, of course, the question, and as you say, it's very complex, and I mentioned some example. We had a really complex modernization project. We have 4 different vendors, and of course, we spent a lot of time. All the vendors could be down in the plant for many weeks, doing plant downs, go through all the material. So we had a really open process, letting the potential vendors understand really what we want to have. So I think it was a successful project until we started really doing the work, because then we understand it was more complex than we ever had thought about it. So yes, I think we learned, but we could learn even more. So I don't really have the answer. We have tested a lot of different way and approaching this kind of, well, get a project flying with the right supplier, but well, help me out. I don't have really the recipe today.
Yes. Oh, sorry.
Maybe I can make one suggestion. Indeed, these are complicated processes, but both overweighing risk and underweighing risk should be avoided. And one way to deal with that is to keep the process open and transparent until the risks are really known and could be well evaluated, and only at that point of time fix prices and fix risk. So that's maybe one way to deal with it. And the other one is also, I would say, a golden rule is that the one to carry the risk is also the one that is best fit to carry the risk. So make sure where the risk is either by the utility or by the supplier, if that is a risk that can be managed by that party.
Thank you, Ad. Well, we are reaching the end of the time which was allocated to us, so I really hope that you enjoyed that lively discussion. If you did, I would suggest that you join me in thanking the panelists.